In 10.4, we're going to talk about factored form of a quadratic equation. So we've already talked about vertex form, and we've talked about standard form, and then the third form we're going to talk about is factored form. So what is factored form of a quadratic equation? Well, factored form talks about 2 points in our parabola that are called x-intercepts. Now, we briefly talked about these in Learning Target 10.1. So let's kind of review what those are. So x-intercepts are where the graph touches the x-axis. So in this graph, that's this point right here, and this point right here at x equals 3 and x equals 5. And we write x-intercepts as coordinate pairs. So 3, 0 and 5, 0 are my x-intercepts for this particular quadratic function or parabola. Okay. Something kind of cool to note is that if I label the axis of symmetry, which by now we should know is that invisible line that cuts right through the middle, is that the axis of symmetry is always halfway between the x-intercepts, which is just kind of an interesting pattern in your parabolas. So that axis of symmetry, the vertex, that line that cuts to the vertex that's invisible, will always be halfway between. So notice that it's 1 unit each to the axis of symmetry from both those x-intercepts. Okay, so the x-intercepts play a really important part of the quadratic function because they're what we call solutions to the equation. Now, we haven't talked about solving quadratic equations yet this year. We can solve linear equations where, you undo each side, get x by itself, get x equals a number. We can also solve quadratic equations, and this is kind of the first step to thinking about what those solutions look like. So solutions to a quadratic equation, okay, are the points at which the function intersects the x-axis. Okay, so solutions are those x-intercepts. So in this case, the solutions to this parabola would be 3 and 5. Now, these have lots of different names, and we talked about this, I also think, in 10.1, but we can call these solutions, we can call them zeros, we can call them x-intercepts, and we can also call them roots. I think roots is a new word. I don't know that I've used that word yet, but we can call them roots. So all 3 of these words, basically 4 of these words, solutions, zeros, roots, x-intercepts, all really mean the same thing. The place where the parabola touches the x-axis, okay? So a quadratic formula or quadratic equation in a graph can have 3 different types of solutions. So if my graph has 2 solutions, that means that I've got 2 x-intercepts. So my graph could look like this. This is one example because I've got a solution here and a solution here. So a 2-solution quadratic function will touch twice. Okay? And it could go up, it could also go concave down as well. But if you've got 2 points where it touches the x-axis, that's 2 solutions. If you've only got 1 solution, that means your parabola looks like this, where the vertex only touches the x-axis. So it only touches once. And that could also maybe look like this too. Something like that, where the vertex is physically on the x-axis. That's a 1-solution or 1-root quadratic function. We can also have a quadratic function that has no roots, that has no solutions. And that's going to look like a parabola that just exists in a quadrant. Something like that, or maybe something like this. And that's it never touches. So it's very possible that your graphs may not have solutions. Okay, we actually call those complex numbers, and we'll talk a lot about, you'll learn a lot about those in Algebra 2. We're not going to touch too much on it in this class, but this kind of graph where it doesn't touch the x-axis at all is a very special situation with no real solutions, keyword real. It does have complex solutions. Okay, so these are the three types of parabolas we're going to be looking at and talking about in terms of x-intercepts in factored form. Okay. So let's kind of review a little bit here in this next part about using binomials to help us with these other forms. Okay, so I've got these two equations. Okay, y equals x minus 2, x plus 4. So this guy right here is in factored form. So factored form looks like this, where I've got a binomial times a binomial. Okay, so this is factored form. This guy over here, we've already learned, he's in standard form. And I'm going to show you that both of these equations are the exact same graph. Okay, and I'm going to show you why. So if we remember from last unit, if I do my Punnett square, and I put the x minus 2 here, and the x4 here, I fill this out, I get x squared minus 2x, 4x, and negative 8. And then I'm going to combine my like terms. I get x squared, because that's right here. 4x and negative 2x give me plus 2x, and then I just bring down the negative 8. Notice that those are the exact same equation. This is factored form of this standard form. Okay? So they mean the same, they will graph identically, but the forms can tell us different things. For example, we learned in standard form that I'm going to have a y-intercept at negative 8. Like, we learned that. So I can go ahead and just draw that point right here. Okay, and now I'm going to use my calculator to get the other pieces of information, and we're going to talk about what factored form does, which is kind of cool. So when I go to put this in my calculator, I'm going to go to y equals, clear out, and I'm actually going to put in the factored form. So I'm going to do x minus 2, parentheses, x plus 4, parentheses. And I'm going to go to graph. And it's going to look just like a parabola. And we're going to notice that this graph does touch at, you can't see it very well, but it does touch here at 8, okay? Now that helps me a little bit. I'm also going to notice 2 in my graph. It's also touching here at what looks like 2, and it's also touching here at what looks like negative 4. Now, if I notice in my equation, do I see a 2 and a 4 in my factored form? And do those two numbers kind of go with the x intercepts? Yeah, that's what we're seeing here as a pattern, is that in factored form, I can get my x-intercepts by looking at the two numbers in the parentheses. Okay, so I'm going to go to my table to get more specific points here. So I'm going to go to my table, and I'm going to plot some of these points. So I've got negative 4, 0, negative 3, negative 5, negative 2, negative 8, negative 1, negative 9. I've already plotted that 0, negative 8, right? That's the point we got from standard form. 1, negative 5, and then 2, 0. That's plenty of points here to get my curve. Okay, and now what we're really looking for here are those x-intercepts. So I'm going to circle them. So I've got 1 right here and 1 right here. Notice what these values are. 2, 0, and negative 4, 0. Notice that that's the same numbers as here and here, just opposite signs. Notice that the x-intercept here is negative 4. My 4 in my equation is positive 4. My x-intercept here is positive 2. In my equation, it's negative 2. So that's the pattern we're looking for here. So when I look at factored form, this is the equation right here. I'm going to highlight it. Okay, where these two numbers, R1 and R2, are your solutions. Okay, so that's what we're looking for in factored form, are my x-intercept, solution, zeros, roots that I get from that equation. Okay, so what am I going to be expecting you to do with this information? Okay, well, first, I'm going to be expecting to be able to graph it and point out what the x-intercepts are. That's an expectation. The second expectation is being able to convert factored form into standard form. You've got to remember standard form is ax squared plus bx plus c. That's standard form. And so what I'm going to want to do is I'm going to want to do a Punnett square for these. And I'm going to ignore the 2 for right now. I'm going to ignore him. I'm going to just do the Punnett square for x and 1 and x and -4 first. Okay. So I'm going to bring this 2 in the equation. Let me zoom in just a little bit because it's kind of hard to see here. Okay. I'm going to put the 2 here in front. And then I'm going to fill out my Punnett square. So I've got x squared here. 1 times x is x. You can put 1x if you want. This would be -4x, and this is -4. I'm going to combine like terms, but when I do this, I'm going to put my new polynomial in parentheses because I'm just converting this. I'm not converting the 2 yet. So the 2 stays in front, and in parentheses, I'm going to have x squared minus 3x, because -4 plus 1 combines into -3, minus 4. Now this isn't in standard form yet. I have to distribute that 2 to each thing inside, and I get 2x squared minus 6x minus 8. That is now in standard form. This was in factored form. This is in standard form. Okay. So now I want you to pause. I'm going to have you try this one. Okay. Oops, that's kind of off the screen here. I'm going to have you try part B. Okay. So you should get this as your solution, y equal, or as your standard form rather, not your solution, but as your standard form, y equals 3x squared minus 21x plus 3. Okay. So that should be the word, and I'll check your work when you come check out with me, but that should be what you get when you do the Punnett square and you distribute. So that's one expectation, is converting factored form into standard form. Okay. Another thing that, like I said, I'll be expecting you guys to be able to do is graph the function and identify x-intercepts and axis symmetry. Okay. So we're going to ignore this right here, cross this off, because we're not going to do this yet. So just ignore that. We're going to write them as coordinate pairs. Okay. So before I even put this in my calculator, I want us to be able to point out x-intercepts without graphing. So when I look at this, I see a 5, and I see a positive 5 and a positive 1. That tells me that I'm going to have x-intercepts at -5, 0 and -1, 0. I don't even have to use my calculator to know that. I'm just going to pull them out, take the opposite sign, and I know I'm going to have 2 points right there, -5 and -1. Okay. I also know that my axis of symmetry is going to be halfway between those 2 points, and halfway between those 2 points is right here. So I've kind of got a little skeleton for what my parabola is going to look like. I also know that this A is 1 right here. There's an invisible 1 in front, and since it's positive, my graph is going to go like this. So these are all things I can predict about my graph before I even put it in the calculator, and that's something that you're going to be expected to do for this unit. There's going to be a no calculator portion of your test, and I'm going to expect that you be able to do these things without using your calculator. And I don't think it's too crazy hard. Okay, so let's put this in our calculator now to see where we can get some other points. So x plus 5 and x plus 1. I'm going to go ahead and get my table and get some points. So I've got a point at -4, -3, -3, -4, -2, -3, 0, 5, and then I'm assuming there'll be 1 at 6, 5 as well. Or -6, 5 if I scroll up. Yep, -6, 5. Okay, so now I've got my points, and everything I predicted was right. I got my 2 x-intercepts in the right place, my graph goes up, my axis of symmetry cuts through the vertex, so I can predict these things before having to use a calculator. Okay. And then the last thing, of course, is once you graph it, I want you to be able to label all of the information on the graph, right? So before I even graph, I can label a few of these things. My zeros are going to be 2, 0. because there's my -2, but when I put it into a point, I change the sign. And my other one is going to be -4, 0. Again, +4 here, but when I put it in here, I change the sign. I know that this is going to go concave up. Okay, and I know that this is not going to be a stretch or a shrink because I've got an invisible 1 here. And that's my A. And that A stays the same meaning throughout this whole unit. It tells you whether it's concave up, and it tells you whether it's a stretch or shrink. So I can guess these things. I can also even know that since this graph is going to go concave up, that it's going to be a minimum. So these are things that I can do without my calculator. The vertex, I could do a little bit of math and maybe figure that out, but let's just go ahead and graph it and find out that way. So go back to y equals in your calculator, and this is x minus 2 parentheses x plus 4. Let's show the picture of the graph. So we can see that I do have my zeros at 4 and -2. And I think we actually graphed this one earlier. This is the graph we did at the very beginning of the lesson. So now we're just kind of talk about what all the vertex and all the things are. So here, it looks like my vertex is right down here, but I can't quite see this on the graph. I think that's a 9. So let's go to the table and plot some points. So I'm going to have my 2 zeros here at -4, and I'm going to have it at 2. I've also got points at -5, 7. Oh, but I can't graph that. So we'll do -3, -5, -2, -8, -1, -9, 0, -8, and 1, -5. Oh, wait, hold on. Sorry, 3, -5. Wait a second. Oh, there we go. These should go down more. Okay, sorry. So -3, 8 down here, -1. There we go. That looks better. Okay, so now I've got my curve. And now I can see there's my vertex right there. And that is at -1, -9. So my axis of symmetry is at x equals -1, which is that invisible line that goes through here. Okay, so factored form is not terrible. We're really just focused in on these zeros and what they look like. I will tell you in the practice, you're going to have to remember this information for a few of them. At the very bottom here, what we talked about with the 2 solutions, 1 solution, or no solutions, that's important. It's going to come up in the practice, even though I didn't do specific examples of that. Okay, so just make sure that that's something you're referring to when you get some of those problems in the practice. Good luck.